So we've talked about the default constructor and the copy constructor. There's still some more methods that are kind of significant in C++ when you're writing classes. The next one is the assignment operator. So what if instead of doing that, I had code doing whatever, and then we say G equals F. Okay. This is doing an assignment. An assignment is very much like a copy with one difference. When you're calling a copy constructor, because it's a constructor, you're guaranteed that there was nothing set up in here previously, so there's no cleanup that has to happen. When you're doing an assignment, you generally need to do all the copying, but you might have to clean up some stuff first. So once again, by default, C++ will create something for you. And this line of code is perfectly happy even though I haven't told this class how to do an assignment. Because what happens by default is there is no cleanup, pretty much. And so the string will do whatever assignment had been written for the string. So it will be handled properly. But for the primitive types and the pointers, there is no cleanup. Okay, so whatever this pointer had been pointing to previously, we're just going to throw it away, which means that we'll have a memory leak because we didn't delete that memory that we had allocated. And then it will copy the value of the pointer in the other object to this pointer, which now means that we once again have an alias, which is probably not what we want. So if you are going to have pointers and things, you almost always need to have a copy constructor. The copy constructors in C++ need to return references to the object that was assigned. They can generally be const objects. You probably shouldn't be changing them. Operator equal. And as with the copy constructor, we're going to pass in a const reference to the object. Whereas the constructor can have an initializer list, the initializer list doesn't make sense here. If b is not equal to null pointer, delete b, I'm assuming that it was pointing to something valid. Then I can do all of my copying stuff here. So a equals f dot a, b equals a new int. I'm just going to follow the code that I had above. You probably should not be allocating one int like this, but that's what I have above, so we'll go with it. Equals star of f dot b. So I allocate a different int and then copy the value over, and then s equals f dot s. So once again, the assignment operator needs to have something that cleans up anything that had been allocated before actually doing the copying. And the copying can't happen in an initializer list the way that it can in a constructor. Another method, this one really in some ways, I guess, well, it is provided by default for you, and by default it once again calls the things appropriately for other objects and does pretty much nothing for the primitives. That is a destructor. So whereas constructors are just the name of the class, a destructor is a tilde followed by the name of the class. You don't get to pass anything into your destructors, and this is supposed to clean stuff up. So for this particular class, the only thing I would need to clean up would be to delete B. There could be more elaborate stuff that you have to do in here, but this is to free any resources. If you had opened a file, you need to make sure you close the file. If you've allocated memory, you need to free up that memory. Whatever it is that you've done in the class that allocates resources, the destructor needs to free those things up. So the destructor is called in, well, one situation is when something passes out of scope. So cout, we'll see when this prints and how many times it prints. Hey, copy. I'm obviously not, I've been loose and easy with my pointers in here, and I've clearly done something that has made this unhappy. So F is created, okay, this line right here, if F was a null pointer, so how about we protect this? If F dot B is not equal to null pointer, then we can do this. And same thing down here. Because if F dot B is null pointer, I should actually have an else in there. If F dot B is not equal to null pointer, then I want to do those things, else B equals null pointer. Else B equals null pointer. Because I can't show you the destruction of things if I can't run it. Okay, so what's going on here? We go back down to our main. I create an F, I create a G. Right now I'm only making one copy, that is in the call to bar, and that makes a copy into here. Turns out this first destruct is happening at the end of this function, because this object foo passes out of scope and at the end of this. And that's the first place where destructors are called. If you have a local variable, so it turns out these other two destructs are the F and the G basically dying when we get to the end of main. So whenever a function exits, any local variables, whether they're declared locally or passed in, have their destructors called. Also, if you call delete on memory you've allocated, you're going to have a destructor called on that. Or if other code winds up calling delete. Basically, yeah, anything that winds up freeing an object from memory is going to wind up calling the destructor on it as well. So, your assignment operator is used when you do assignments in code, and that is different from the copy constructor because it also needs to deal with any state that had already been there. The destructor, which begins with a tilde followed by the class name, is used to clean up whatever resources you had allocated. In some ways, the operator equal is almost like a destructor followed by the code for the copy constructor. There probably should be, I'm not handling this properly here, when you write these things, there should be a special case that if you do a self-assignment, so if I say F equals F, we should probably short circuit out of there so that we don't mess things up. Oh hey, and I'm not returning. I'm not doing a warn all. That's why it didn't give me a warning on that. Return star this if at F equals this. So when I take the address of the thing that F references, if that happens to be the same thing that this is in C++, this is a pointer. By that I mean this is a pointer. It's not an actual object or a reference. Return F. That way we'll break out there. Okay, and I won't have problems if I do self-assignment. So those are the other two special methods, and prior to C++11 we've now covered all of the significant special methods. Beginning with C++11 though, there are some additional ones that need to be considered as well.